We're now going to continue our Paris Mat Rendez-vous with a new roundtable. We're going to be talking about environmental issues in the air transport sector. I'd like to welcome Jean-Claude Guez. You're Director of the Air and Spatial segment of underwriting. Multiple choice question. We're going to call on the audience here. Multiple choice question. It is as follows, and you have 30 seconds to answer so that we can count the votes and react to the matter. According to you, what source of onboard energy is most likely to decarbonize air transport by 2050? You have 30 seconds to answer. Jean-Claude Guez, could you introduce your speakers? I'd like to say hello to you all, first of all. On behalf of the organizing committee of Paris Mat, I would like to thank Michel Wackenheim, Eric Dautria, and Bruno Stoufflet, President, Vice President, and member of the Academy of Air and Space, for having accepted to share their vision with us and their thoughts about environmental matters and air transport. The goal of the workshop is to shed light on the way in which the air transport industry will be able to contribute to international expectations when it comes to CO2 emissions. We'll look at the implications for all the players in the chain, including the insurers. During this hour we have together, we're going to deal with climate change in air transport, technological solutions which will make it possible to reach carbon neutrality, and with what degree of reliability and safety. We'll also look at what this means for air operators and the role to be played by international organizations. And at the end, what are the prospects for all these players in air transport, including insurers? So, we have our answer. I'd like to thank the audience for participating. The answer, 68% hydrogen, synthetic fuel, 12% batteries. That's the feedback. That's very interesting. I'll launch the debate. The COVID-19 crisis has led temporarily to a reduction in CO2 emissions, but it's also reinforced global awareness of the need to act in order to attain the goals in terms of greenhouse gas emission reductions or carbon neutrality in the next decade. I'd like to turn to our guests and ask them, according to you, what are the challenges of climate change when it comes to air transport? We all have in mind the objectives of the Paris Agreement, ratified by many, limit global warming by less than 2 degrees by 2050 and achieve carbon neutrality as soon as possible. Michel, would you like to get the ball rolling when it comes to the challenges and perhaps remind us of some of the data when it comes to the carbon footprint of the air transport industry and its commitments? Well, facts and figures. The Academy of Air and Space organized a symposium recently with the participation of a vice president of the ENG group, and I'll quote the figures that she herself gave. CO2 emissions, direct emissions of CO2, greenhouse gases for air transport represent 2.4%, according to l'UGEC. Of course, there is some uncertainty, but 2.4% of the whole, of all the emissions. If you include the indirect effects, because there are other kinds of greenhouse gases apart from CO2, you have, for example, the effect of what we call the condensation trails. That would amount to 3.5%, and these are the rough figures. I'm not going to say that this is absolutely 100% accurate. However, it is a sector which represents a small part of CO2 emissions. However, that doesn't mean you shouldn't be concerned with this for the future, and one can aim to reduce emissions in the decade to come. That is a key fact. If you compare, for example, with CO2 emissions caused by the internet, it's 3 times less than the internet. Let's state this clearly. It's 3 times less than the internet. So in fact, there's a matter we'll no doubt revert to, namely the production of green electricity. The problem of electricity is the key issue in many sectors. Now, in terms of challenges, of course, I'll give time, of course, to my colleagues to take the floor and to round off what I'm saying. I will limit myself to the geopolitical dimension. That also is a key issue which one can wonder about. At what level should one deal with this matter of greenhouse gas emissions by aviation? Can one deal with this on a national level, or should it be a continental level or a global level? And I'm putting this question because the answer is that it has to be addressed globally. Why? Because air systems are intermeshed to such a degree that it's very difficult to share out the volume of emissions per country. And that is something that was already identified when the Kyoto Protocol was signed in 1997. At the time, the OACI, the international organization IATA, and OME, for the maritime component, were entrusted with the defining policy to reduce CO2 emissions. It wasn't a treaty in Kyoto or in the Paris Agreement, in fact, because the Paris Agreement followed on the preceding stages. That doesn't mean this doesn't have to be dealt with. It just adds an additional burden to the air sector, which needs to organize global governance that really works to reduce CO2 emissions due to aviation. So the stakes are high. They're political, they're geostrategic, and over and beyond these legal and political issues, you also have international challenges in terms of the solutions we'll be talking about. What I'm trying to say is that the air sector, the air market, the plane market, the air transport market is by nature international. Planes are designed to fly a long distance and often at very high speeds. When it comes to technological strategies which will be adopted in the future, one has to take into account this international dimension, because you don't sell planes in just one country or in just one continent. I won't go any further. I'll give the floor to my colleagues, and we'll probably revert to all these topics in the course of the discussion. Thank you, Michel. Air carriers, the whole air transport industry has made commitments to reduce emissions. Indeed, it has pledged to scale back the emission of greenhouse gases. Eric, would you like to take the floor on that topic? Yes, commitments or pledges were made a good 15 years ago. The first date from the year 2000 in Europe. Goals were set out in Europe, and there are other international pledges, and they're pretty consistent. We considered initially that the goal was to divide by 2 CO2 emissions by 2050. Now, the goal is to reach zero net carbon. If you take account of CO2 absorbed by different means, the idea is to reach carbon neutrality. Currently, one can also say that for quite some time now, the air transport sector has been scaling back on carbon emissions, but hasn't called it that. Over 50 years, approximately, there's been a 70% drop in the consumption of fuels, in liters of fuel per passenger kilometer. This was linked largely at the outset to economic reasons. And in fact, it has led to a reduction in CO2 emissions. Now to talk about another challenge mentioned by Michel earlier on a global climate level, I'd also like to talk about the fact that it is urgent to act. As you know, CO2 is a cumulative effect, and currently CO2 emissions will continue to increase up to the year 2050, roughly speaking. And it's become an urgent matter. It's absolutely necessary to find solutions. It's a very important point. Another challenge is political and social. Is the social acceptance of air transport in the future? There's quite a lot of passionate discussion about this today. It's not always rational. We'll talk about that later on too, no doubt. However, this is something we have to take into consideration. The professional air sector also has to take it into consideration. A further comment on electricity. Why is electricity a challenge? I think it is too. It is a common denominator in almost all the solutions in an indirect manner. Yes, when it comes to technological solutions, Bruno, what are the main challenges from that stance? Perhaps then we can develop all the various technologies which are available for the air transport industry. I'm Bruno Stoufflet. I'm Director of Research and Innovation for Dassault Aviation. For many years now, I've been involved in the general roadmap. You know, the aeronautical sector is extremely well organized and quite exemplary in this respect. All the industrial players, all those in research, are working on the same technological roadmap in order to take up the challenges just mentioned by the two preceding speakers, both on a French level in CORAC, for example, and also on a European level, because there have been any number of partnerships that have built up. Clean Sky 2, and so on. So I'm going to give a sort of a group answer. What is the overall area preparing? As you know, mass is the main discriminating factor when it comes to aviation. This can lead to different solutions compared with maritime or terrestrial transport. Hybrid energy could only be for planes that cover less than 1,000 kilometers in terms of radius, even if you take account of progress and new batteries with 400 or 500 watts per kilo. We won't be able to fly planes for more than 1,000 kilometers. So hybrid solutions are for short-range planes. 85% of greenhouse gas emissions are due to flights over 1,000 kilometers. So the electricity as an input will have a minimal impact. It might be used for urban reasons, but basically, for the time being, there's just the thermal engines, really, which are solutions for business aircraft or for commercial airlines. Of course, we'll have to replace fossil fuel by other kinds of fuels. What are we preparing for the future? I think we can talk about 4 pillars. The first is to improve what we call the airframe. That is the plane which will be equipped with engines. Improve the airframe and the engines. There are further prospects for improvement still. When it comes to the plane itself, we're working to prepare different wingspans from today, longer planes or wingspans with less drag, more laminar profiles, reduced drag, in other words. And one can save 10 to 15%. Perhaps the cost will be to reduce speed, but we don't yet know today. For a trip that lasts several hours, that may not be too heavy a price to pay. So there are prospects. And on the engine side, Safran and GE are imagining new architectures for engines in order to gain up to 20%. 10% with the airframe, 20% with the engines. So we're still in a position to gain 30% overall. It's not enough, of course. There may be other ways of lightening the plane. We could go up to 30%. That is true of the successor of the A320 or a business aircraft. That's the next generation. That's for the next generation of planes and engines. That's what's possible. So that's really worth it. Pillar number 1 in the short and medium term is biomass fuel, sustainable fuels, or electricity, for example, part electricity, part hydrogen, captured CO2. But that is only possible if we've made progress on plane design so that the need is compatible with what will be available. Currently, air transport consumes 300,000 tons of fuel per year. By 2050, it'll be 1,000 million tons of jet fuel. So if we achieve these gains of 30% and with a bit of luck 50%, 500 million tons, well, according to the general consensus, that may be possible. Of course, there may be other usages which become available, but in aeronautics, we need sustainable fuels. Land transport will probably become more electric, shipping more hybrid, I don't know. So we need to improve the technologies. This will provide a medium-term solution, which we can, of course, discuss further. This all means you need to have fuels available at a cost which is affordable. That's the second pillar. Third pillar is the ability to improve the actual running of planes. There are further gains which are possible, either in terms of the landing or takeoff, avoid waiting times. Air traffic has improved, of course, but we can improve further. And we can improve long-haul aircraft, make the most of weather in real time and winds. That can lead to 10 to 15 or 15% reductions. You can gain 10 or 15% in long-haul flights if you make better use of winds than today. That's very appropriate for business travel, business aircraft, which can optimize their routes more. 10 to 15%, that's quite a lot. But the plane is what it is. You don't have to develop it in any way and move on to a further generation of aircraft to benefit from the winds, for example. So these are things which in the short term are very effective. Fourth pillar, imagine disruptive developments in the future, go beyond synthetic fuels and move on, for example, to very, very clean fuels like hydrogen, which is a candidate that's fairly typical today. And that is why, as a group, we have launched various developments which, we're looking at the technological feasibility for the time being, and that's been accelerated by the National Recovery Plan, and a lot of support is being given to this area. Those are the four pillars. The horizons may be different: short-term, operational, medium-term, redesign, and hydrogen for 2035 or beyond. Okay, let's have another round of contributions, but first we'll take some questions. The emissions you mentioned when comparing with the internet, The question is, do the figure include the airport infrastructure emissions? Quite frankly, whether they're included or not, the orders of magnitude are the same. Emissions linked directly to airport activities are very, very low compared with the bulk which results from the planes themselves. Having said this, airports are making efforts to reduce their carbon footprint, but that's a tiny, tiny component of the overall figure. Second question, less consumption, but more and more air traffic. What would you like to say about that? Can air traffic continue? Well, first of all, it's going to resume. And will it continue to grow indefinitely? In the scenarios, we take all this into account. We are an air transport industry, and we have scenarios up to 2050 or beyond on a European level. ATTAC is an association that brings together all the players in air transport, for example, and we look at the various scenarios. Obviously, we take into account hypotheses as to the increase in air traffic. That's why I was saying that currently consumption is 300 million tons, and it may be 1,000 million tons in the future. That's why we're accelerating when it comes to technological change to go down to 500 million by 2050. But we do take into account in these scenarios the trends in air transport. It's not something that is outside our overall line of thought. Just to round off what has been said, it's true that in the past, gains in fuel consumption, better performance by planes, served inter alia to help reduce the price of air tickets, which encouraged more people to travel. That was a sort of rebound effect. In the future, the new fuels that Bruno was talking about are not less costly than jet fuel. They'll probably be more costly. We don't know to what extent. It will depend on the procedures used and the kind of fuel, but they'll be more expensive. So in that regard, there will be no boomerang effect. Of course, performance will continue to be improved. We're in such an uncertain situation as to the future of air transport, given the COVID crisis and the speed with which the system recovers. Well, we don't really know. I'd like to react to your question. I think behind the question there's something that's very important, namely the evolution in energy efficiency and the impact of traffic, which will be greater than the improvements in terms of energy efficiency. That is why industry, as Bruno has said, is looking for solutions to achieve zero emissions in the long term. That's the long-term goal. In a world with zero emissions, the impact of a growth on traffic, on emissions, will be nil. Once solutions have been found and are implemented that considerably reduce CO2 emissions, or which, in fact, when you take account of the whole cycle, amount to nil, well, that would allow for an increase in traffic, contrary to what some people are advocating. People who don't believe in these technological evolutions are saying, well, as you won't manage this, you have to reduce your activity. Well, stand on your head. That's not exactly what we need now. But what is sought, the ultimate goal, is to reduce emissions at source to bring them down to zero by 2050, sometime around 2050. I don't really know because it's industry that will provide the solutions, but that's the actual goal. The policy is the one I've just described. Now I'd like to add a further minor comment. You mentioned the opinion poll, 68% hydrogen, the solution of the future. It's the solution of the future for planes which won't fly more than 500 kilometers and have only 50 passengers on board. roughly speaking. That doesn't mean, well, Bruno will correct me if I'm wrong. It's not because we know how to do this for small planes that we'll be able to do this in the future for bigger planes. Currently, today, it's only the smaller planes that can use hydrogen, liquid hydrogen. Then there are other means, other fuels, which could be made using hydrogen, but liquid hydrogen, as imagined today, in terms of the future, is limited to planes that fly only short distances. 15%, as you said, that would resolve 15% of the problem. You will have to deal with the remaining 85%. Yes, in studies, we're trying to go further. But the idea is a medium-range aircraft. The A320, for example. Airbus has announced the certification of a plane which will fly using hydrogen by 2035. But we'll have to see what kind of plane it is. Of course, I'm speaking as an insurer when it comes to reliability and risks. These are technological disruptions which may entail uncontrolled risks. I have an anecdote in this area. One of our projects was to use a fuel cell on a plane, on a business aircraft. It was just a test flight, of course. It wasn't for propulsion. It was just to use it as an additional source of energy. And we had an issue with insurance. It was the very first time that I had been confronted with this kind of a problem. And it was a problem, indeed, because you have to reconsider safety studies, and all those involved have to understand what the occurrence of unwanted events might be, and we didn't manage. We didn't manage to solve the problem. So here, I do indeed believe that there's a real issue. How should one share responsibility? It'll be different from a conventional plane. The feared events aren't the same, and everyone has to fully understand where each entity's or person's liability lies and the degree of seriousness of the event. So I do believe that, indeed, this is a good topic for discussions amongst technicians and insurers. Yes, indeed. No doubt. We don't have enough information, probably, so far, in order to assess things as an insurer, in order to assess the risk. Of course, if it's a new kind of physics, this is known on the space side, the level of safety may not quite be the same. So we need to understand the physics to be able to understand the kind of feared events and be in a position to afford the requisite protection and insurance. We've been talking about technological disruption with hydrogen, but to what extent will air operators be prepared to adopt certain new technologies today? Michel, you might like to answer that question because you're Director General of Civil Aviation. It's true. It's an important question. In the past, airlines, as Eric was saying, spontaneously looked to reduce their consumption of fuel. It was in their interest, not necessarily to protect the climate and the earth. We didn't talk about that so much in the past. So today, the world of air transport is prepared to make every effort. That was stated by the Director General of IATA in our symposium. But of course, we're reaching the limits of the economic model. In other words, we're in a world which is highly competitive, very global, very liberal. Let's recall all that, after all. 40 years ago, the world of air transport wasn't so liberal. One could impose very strict rules on airlines without any difficulty. Now, since we've had the liberalization of air transport that occurred in the 80s, that opened up access to the market. It enabled airlines to fix their own rates and offer the kind of capacity they wanted. That's where we stand today. This policy was therefore followed, and this policy does have shortcomings when it comes to the climate, of course. When airlines offer European flights for less than 10 euros per passenger, you can really wonder, have they truly taken into account all the environmental externalities in these prices? When people offer subsidies to airline companies to come to their airports, when the territorial authorities do that, is that an economic model that really is concerned with the environment. So you have all these issues which tend to arise, and then you have questions which go further. Currently, we have regulations on CO2 emissions, or international regulations, which have been adopted by all the states. And these rules apply. All planes are certified, so there are certification rules for aircraft and motors when it comes to CO2 emissions. We have a certain number of other environmental rules as well. There may be some additional ideas when it comes to regulations. This is nothing new. There may be airports or countries which refuse access to certain categories of planes, for example, which are viewed as too heavily polluting. There may also be a temptation to impose taxes depending on the ecological performance of the plane. So there are all sorts of new things which may arise. What we looked at within the Academy of Air and Space needs us to say the following. The time has come. The preceding policy was defined or discussed on a global level about 10 years ago. There was the Air Transport Conference bringing together the 193 or 194 states in ICAO. Is the time to give new thought to the matter, because we may end up in a situation where certain states want to impose certain rules and others won't want to accept these new rules, and we will have difficulties or disputes like in 2012 between the EU and other countries in the world. The EU wanted to impose its system of European DTS, and it had to backtrack because there were real difficulties, major difficulties. So I think we have to anticipate on all these matters and evolutions, which will be very important. And perhaps we need to organize an air transport conference, which would be the 7th in the history of the ICAO in Montreal. And when we talk about regulations, you also have incentives. Bruno was talking about improvements in the performance of current planes. There could be incentives. They might be possible with a view to fleet renewal. Studies have shown that if right away we replaced all the planes, the older generation, by new generation planes, the latest generation planes that are just coming out this year, then we would gain 30% in terms of CO2 emissions. Are we capable of providing incentives that would encourage airline companies to do this?
To add to what Michel was saying, maybe you know that France has adopted a law that will impose incorporation mandates for sustainable aviation fuels for airlines in 2025, so 2%, and if I'm not mistaken, 5% in 2030. This is going to be an obligation for airlines to incorporate sustainable aviation fuels into their regular fuels. now we're pretty far from that, so we'll need to get there, 2025. The engines can run on that, technically no problems. But economically, there is going to be an impact in the economic equation for airlines. And I think that there are going to be European mandates that are going to take over, but I don't remember the exact figures. Well, yes, indeed, that way we can look at the longer-term outlook, and I'm turning to Eric, who chaired Clean Sky, now Clean Aviation. According to you, is air transport going to be carbon neutral in 2050? As we discussed, it's relatively well on the way, technically speaking, but then the whole chain should be involved at the international level with international organizations. So what are the challenges to such a transformation, apart from cost, and also maybe societal implications? I'll let you ponder that. Well, before I start talking about the challenges or the outlook, one thing to keep in mind is a matter of common sense that we discussed in our previous interventions. First of all, we need to focus on what really matters. We talked about the 80% of all CO2 emissions. This is what really matters. If additionally we can have some electric aircraft that can carry 3 passengers at the maximum, it's good, but that's not the issue. That doesn't mean we shouldn't do it, but that's not really the issue. Same thing for fuel cell aircraft. And I would go even a bit further talking about hydrogen, but I'll make an aside about hydrogen because I went through that in my previous life. And also you need to consider all future human needs on a comprehensive basis and not think in silos. Now there's a tendency by some people in the social discourse today, in the public discourse, environmentalists, thinking that each sector had a proportion of its respective emissions in 2018, because 2 years ago that's still recent, and everybody should reduce in proportion to that. But you're no longer thinking about two things, the social utility of a sector, and I think that aviation shouldn't be too shy about a debate comparing its social utility to other things. I won't name names or any other sectors, but just comparing it to other sectors, and also how easy it is to decarbonize, because for cars it's easier to go electric than for aviation to achieve zero carbon. And as Michel said at the very beginning, you need to think on a global basis because it can only be global. Both air transport and CO2 emissions are planetary issues. So any national or even just European initiative would make no sense. Absolutely none whatsoever. And you know what I'm talking about when I'm thinking about the initiative that was adopted by the French government to say that we'll subsidize the aeronautics industry for the post-COVID recovery, provided that it makes a commitment. Well, it makes a commitment to do its best to have a hydrogen-powered plane by 2035. And you also need to remain critical vis-a-vis big announcements, because there are always loads of big announcements, and you need to think about orders of magnitude. This is something that people seldom do when talking about the ecological transition. They seldom talk about orders of magnitude, especially not about biofuels. So you need to avoid greenwashing and green aviation bashing. So aviation in 2050 can be seen from different angles, but they were already discussed. What is difficult to predict is the improvement in performance, the 30% that Bruno talked about. We can hope for better with improved operations in air transport, and it's indispensable anyway, because even if we had a system, and even when we do get a system for zero carbon overall, net zero that's still going to use electricity anyway to produce synthetic fuels. And this electricity is going to be used by everybody. There's going to be a sort of competition on the use of electricity, so that both for economic reasons and political reasons, potentially everybody needs to reduce their needs. There's a matter of sobriety which is central to all solutions. The second item is about biofuels, well, alternative fuels called SAFs, Sustainable Aviation Fuels, including biofuels, first and second generation, and above all, we think the most likely are synthetic fuels, which are now they already exist as experiments. For instance, in Germany, there's already a lot of work that has been conducted on that. So, first of all, you produce hydrogen via water electrolysis, and you capture atmospheric CO2. With that, you build synthetic kerosene that has properties close to current kerosene. It can even be a bit better, given some induced effects on CO2. And then the CO2 is re-emitted in flight, but overall the carbon balance is zero or tiny. It depends on the whole system and its efficiency in terms of transport and such like, but that's the basic idea. Another possible solution is hydrogen. Here I wanted to make an aside. I was the head of launch vehicles at CNES in my past life, and they were the prime contractor for the development, in particular, of Ariane 5, the current launch vehicle, which mostly runs on liquid hydrogen and oxygen. Well, for future planes, we're talking about liquid hydrogen. You can have small aircraft running on gaseous hydrogen, but the mass and the size of pressurized hydrogen, it becomes prohibitive. So liquid hydrogen, what's good is that it's got a very good calorific value, but very low density. So all other things being equal, to replace kerosene on an aircraft like an A320, you need a tank that's 4 times bigger and with great thermal insulation. That's one of the difficulties, and we don't even know whether we're going to be able to solve them. But to go even earlier in the system, you need to produce the hydrogen via electrolysis for it to be green, clean hydrogen. This is shared with synthetic fuels. If you want liquid hydrogen, you need to produce liquid hydrogen immediately close to where it's going to be used, because you can't transport liquid hydrogen. The bad characteristic is that it boils off when it's stored mostly at ambient pressure. It's going to boil off even with great insulation. So you can't have pipelines over 1,000 kilometers to transport liquid hydrogen. It's unimaginable. So you need to liquefy it on site. Liquid hydrogen manufacturing plants in Kourou, there's only one, and it's classified Seveso, high. You're talking about risk, so that's a big risk. And it's several orders of magnitude smaller than what you would need to power Roissy with a similar fleet running on hydrogen. For Ariane in Guyana, when you start filling the launcher, you evacuate the launch area. There isn't a living soul when you start filling, and the launch vehicle can take off on its own. You don't need a pilot. Well, we can also put astronauts on launch vehicles like the shuttle that had liquid hydrogen. It's possible, but that gives you an idea of the difficulties. I was recently reading in the press that Aéroport de Paris started a study with Air Liquide, and the first ideas that are coming out of that is that you're going to need a specific area for hydrogen aircraft. They're not going to mix with kerosene aircraft. That should still exist. And another thing, for the airport, it's a paradigm shift. And if only Roissy is equipped, well, planes are not going to fly very far, are they? And since you're talking about a global transport system, the whole world should equip with such systems. That's colossal. Imagine that all major airports in the world would equipped with such systems. Even if that's not for long hauls, A320s are sold worldwide. So yes, indeed. And this hydrogen solution is far from obvious, and that raises huge challenges. And I think that if you were to conduct a poll, maybe you wouldn't get the same answers now. What matters is what you said. It's not just about flying a hydrogen plane. You need the infrastructure on the ground around it. And what we discussed with the small fuel cell was that ground handling was the problem. It's not putting it on an aircraft. So don't forget everything that happens on the ground before the plane takes off. Maybe there are a few questions. Well, you've built this multiple choice questionnaires to get the ball rolling before the. What would have been your answer? Were you surprised by the fact that hydrogen ranked first amongst the respondents? Yeah, I was surprised. I didn't think it would be so much because the difficulties are sort of known with hydrogen. Well, of course, there's been a lot of hype in the media that may have counterbalanced these reservations. But yes, I think that flying aircraft will get there, but then having a system that's viable with the infrastructure that you mentioned, and then you're going to have to deploy that to several airports. That's going to be a huge problem. And that may be a word of conclusion for you, Bruno. Maybe we'll get planes in the air, but the infrastructure is the crux. I'm sorry, this is almost the end of our discussion, but if you want to share a few closing comments, Michel, in just a few words. What we've said is about system interoperability. The air aviation system has to be interoperable, otherwise you can't fly planes everywhere. Aircraft need to be able to land on a large number of airports in the world. For technical reasons, an organization was created for that. This is the role of this organization. I'll focus on that, not because I chaired its assembly, but because we need international agreements on technical matters, on standards, so that we can implement all these innovations. Don't forget, there needs to be certification for all these systems, and not just European certification, but global certification. So in the US, in the EU, and other countries. And I'll also focus on one thing. There should be a better international consensus on the goal set for the aviation sector. We talked about European goals first, but there are no global goals. There is no statement that says international civil aviation, for instance, will achieve carbon net zero by 2050. This is found nowhere in international texts. We think that we need to go through that step, and there's a great opportunity next year with a general meeting of all member states of ICAO in Montreal. We need to prepare for that. France is going to be the president of the European Union in the first half of next year. It's a good opportunity to start thinking about progress in this area. Otherwise, you'll run into endless debates between developed countries and developing and emerging countries. Some want to set very ambitious goals. Others are going to say, well, no, we're not fully at the source of the current situation, so you need to make bigger efforts than we. We'll make efforts later. That's the dispute right now in the discussions in Montreal between shared but differentiated responsibility that is found as found in the Paris Agreement. Well, the Paris Agreement gives shared but differentiated responsibilities, and the non-discrimination principle, which results from the Chicago Convention. So we recommend a strong political initiative before next year. Thank you, Michel, for this strong conclusion, which deserves to be shared. Eric, a word? Well, we haven't really talked about social or societal matters, the image of air transport and so on. But I think that we need to avoid having short-sighted and oversimplified reasonings based on shaming and moral positions that refuse to think about technical solutions. Thank you, Eric. Yes, indeed. I think maybe we have a question. Yes, there is a question which is not too much about solutions, but about the context. I'll read it. The CSR policy of major key accounts are more and more sensitive to the carbon impact. Isn't that a fragility for the international air business, which is sensitive to business travel? Well, yes, indeed, there's been a sea change in terms of business travel. Using video conferencing more and more now, but at some point you'll have to travel just for basic human relations. I'm always saying that business travel accounts for 2% of air transport. So business travel, of course, is very much exposed to what we were saying, but it only accounts for 2%. So you're in the same situation as air transport vis-a-vis the rest of human activity, 2% of 2.5%. However, what I think is that there are going to be changes in the way business travel is used. It's going to be a lot more shared. That's my personal view. So there are quite a few people who are probably going to reduce the number of trips and who are going to focus on travel on planes with better conditions. Business travel is mostly for people working while they travel. Well, there are some excesses, but we're talking about people working during their trips. So there's going to be a whole class of people who have their economic utility when they're traveling, and so they're going to move to business travel for better health conditions and also easier trips. With business travel, you can travel from A to B as close as possible to where you want to go, and that also has beneficial impacts in terms of emissions. Yes, it's also worth reminding ourselves of that. This is now the end of our discussion. As an insurer, I'm still confident about the ability that the air value chain has to achieve carbon neutrality. In my 30-year career, I've seen the number of accidents reduced by almost 80%. Well, we're talking about roughly the same challenge, but now, of course, this requires a concerted effort by everybody, a holistic approach, and including by governments. If you want to know more, because the Air and Space Academy organized a symposium on the climate challenge and air transport, you can find that on the Academy's website. And regarding the impacts on risk control, we'll see you in 2022, because we had postponed the topic of a roundtable on the future of innovation, technological outlooks and impacts of technological risk. We'll see you in 2022 to discuss that with aspects of risk control and risk management. Thank you so much, gentlemen, and thank you for your attention. Thank you very much indeed to all for this high-quality discussion. We were able to take time to talk about the solutions and the context. It was very interesting. Thank you to the people involved in the chat. Also, we're trying to answer all your questions with the speakers here. after our partnership break, so that we can watch different videos with our tech partners with ideas of innovation, then we are going to talk about the environment again, but from the maritime perspective, with the changes in the maritime sector in terms of air pollutant reductions.